A boat on the Potomac River travels the same distance. Stop. I see the phrase same distance downstream in 2/3 hour as it does going upstream in 1 hour. If the speed of the current is 3 miles per hour, find the speed of the boat in still water. Okay, I'm noticing here that I have a same distance, and distance is equal to rate times time. So I'm going to write rate times time is equal to rate times time. The first one will be my distance downstream, and my second one will be the distance going upstream. Okay, let's take a look here. And let's move that up a little bit. 2/3 hours downstream. That is a time which is going to be 2/3. Now, and it will take 1 hour going upstream, so we have a 1 right there. If the speed of the current is 3 miles an hour, now downstream you're going to have the speed of the river plus 3 for the boat, because you get that extra boost from the river. Going upstream, however, the river is working against the boat, and we're going to have R minus 3 as the rate. Now what I want to do is I want to multiply through by 3 in order to clear the fractions, because I don't want them in my equation any longer. And so on the left hand side it will cancel, just leaving 2 times the R plus 3, which is 2R plus 6. On the right there's nothing to cancel with, so we have 3R minus 9. Now we have a linear equation to solve. Subtracting 2R from each side will give us R by itself on the right, and I'm going to add 9 to each side so that I can get right to my answer. So I'm going to have 15 on the left is equal to R, so my answer here is 15 miles per hour is the speed of the boat in still water. That means it's the speed of the boat on its own without any consideration from the current. A pharmacist needs to mix a 1% saline or salt solution with 24 milliliters of a 16% saline solution to get or obtain a 9% saline solution. Okay, definitely a mixture problem, and here will be my mixing containers to mix them in. Prices and percents go on top and the amounts go on the bottom. So I've got a 1% solution, and we need to mix it, we don't know how much of it, with 24 milliliters of a 16% solution to obtain a 9% solution. Well, how much is in that? Well, the 24 milliliters plus the original amount, so we'll have X plus 24 there. Now, when I go to write my equation, we'll be going top times bottom plus top times bottom equals top times bottom. And since each of these is a percentage, I can just multiply through by 100 and clear the decimals. So I'm just going to write this as 1x, or x, plus 16 times 24 is equal to 9 times x plus 24. Here we go. X plus, now maybe you need some scratch paper over on the side. 16 times 24, that gives us 64, 0, 32, 384. Oops, sorry about that jiggle. 384 is equal to 9x plus, looks like we need some scratch paper again. It's time for 24 times 9. 9 times 4 is 36, carry our 3, 18 plus 3 is 21, so 216. Okay, continuing on. We're going to get all the x's to one side, which means I'm going to subtract x on each side. That will leave me with 8x on the right. And while I'm at it, I'm going to subtract 216 on each side, and that will leave me with 168 on the left. So dividing each side by 8, I'm going to get x is equal to 21 milliliters. And that is how much of the 1% solution should be added.